learn like a pro.
Hey, welcome. Think of this as your personal crash course on the world of acids. We're going to break down everything, from the sour taste in your food to some really cool reactions in a science lab. So let's just jump right in. It all starts with a pretty simple question. That unmistakable tang you get from stuff like lemons or vinegar, well, that's actually chemistry in action. And the star of that show is a family of compounds we call acids. So, what is it? What's the secret ingredient that makes something acidic? Let's peel back the curtain and look at the one thing that truly defines what an acid is. And there it is. That's the core idea, right there. An acid is anything that, when you dissolve it in water, lets go of hydrogen ions. We like that as H+. This one little action is the key to everything else we're about to talk about. And acids are absolutely everywhere. On the left, yeah, you've got the super powerful ones you'd find in a lab, like sulfuric acid. But look at the right. They're in your kitchen, too. Malic acid is what gives apples that tart kick. And ethanoic acid, that's literally what makes vinegar, well, vinegar. Now, this whole process of releasing hydrogen ions has a fancy name: ionization. It just means the acid molecule is splitting apart in water. So if you take hydrochloric acid, or HCl, it splits into a hydrogen ion, the H+, and a chloride ion, Cl-. Simple as that. But here's a super important point. Just because a molecule has hydrogen in its formula doesn't automatically make it an acid. Take methane, CH4. It's packed with hydrogen atoms, right? But it's not an acid because it holds on to them. It doesn't release them as H+ ions in water. Remember, it's the release that matters. Okay, so if we can't just look at a formula, how do we actually know if something's an acid? Well, luckily, chemists have some really simple but very cool tricks for spotting them. Acids have a pretty distinct set of properties. We already talked about the sour taste. They can also be pretty corrosive, and when they're dissolved in water, they can conduct electricity. But the classic go-to test, it's the litmus test. You take a piece of blue litmus paper, add a drop of acid, and bam, it instantly turns red. So identifying acids is one thing, but where they really shine is when they start reacting with other substances. This is where we get to see what they can really do. Let's see them in action. So our first big reaction is what happens when you mix an acid with a reactive metal. Think of something like zinc or magnesium. The result is always the same. You're going to get a salt, and you're going to get hydrogen gas every single time. A great question to always ask in science is, how do you know for sure? I mean, you see bubbles. Sure. But how can we be absolutely certain that gas is hydrogen and not, say, just air? Well, there's a simple and pretty famous test for that. It's called the lighted splint test, or sometimes just the pop test. It's awesome. You collect the gas coming off the reaction, and you bring a lighted wooden splint near the opening. If it's hydrogen, the gas ignites with this really distinctive pop sound. It's a dead giveaway. All right, on to our second big reaction. This is what happens when an acid meets a carbonate. Carbonates are in things like chalk or seashells. When they react, you get three products every single time: a salt, water, and carbon dioxide gas. And just like we had a test for hydrogen, we've got one for carbon dioxide too. What you do is bubble the gas that's produced through this clear liquid called the lime water. If it's carbon dioxide, the lime water will turn all cloudy and milky. That's because a white solid, we call it a precipitate, is forming. Now, it's really important to get this. Not all acids are created equal. Some are incredibly powerful, and some are much, much milder. And the difference between them? It all comes back to that key process we talked about right at the start: ionization.
So here's a breakdown. A strong acid, like the hydrochloric acid in your stomach, ionizes completely. That means every single molecule releases its hydrogen ion. It's an all-or-nothing deal. But a weak acid, like the ethanoic acid in vinegar, only ionizes partially. Just a small fraction of its molecules are letting go of their H+ ions at any one time. And you can see the result right here. If you have the same amount of both, the strong acid makes way, way more H+ ions available than the weak acid. That huge concentration of reactive ions is exactly why strong acids are so much more, well, reactive and corrosive. So, what happens when you mix an acid with its chemical opposite, something called a base or an alkali? Well, you get a really special, really important reaction. It's kind of like the ultimate chemical balancing act.
The reaction is called neutralization. And the outcome is just beautiful in its simplicity. An acid and a base will always neutralize each other, and the products are always a salt and good old water. So if you strip away everything else that's going on, the real heart of every single neutralization reaction is this one simple event. The hydrogen ion, H+, from the acid gets together with the hydroxide ion, OH-, from the base, and they form a stable molecule of water. That's it. That's the essence of neutralization. All right, we have covered a ton of ground, so let's do a super quick knowledge check just to see what stuck. No pressure at all, this is just to help it sink in. You've got this. Okay, first one. What gas do you get when you mix an acid and a reactive metal, and how do we test for it? If you said hydrogen gas and the pop test, you are spot on. Excellent. Okay, next up, an acid reacts with a carbonate. What are those 3 products you always get? That's right, it's a salt, water, and carbon dioxide. Well done. And for the last one, what do we call that special reaction between an acid and a base? It is neutralization. Fantastic job. Seriously, from the food we eat to the world around us, understanding acids is a huge part of chemistry. And now you've got the foundation. Great work.